Hello, in this video we are going to cover second part of atomic subsystem, that is the function packaging and the code generation optimization. For the simplicity, two subsystems, one is the non-atomic one and one is the atomic one. Same set of input parameter will go and get executed, even the logic inside is remains same. So two inputs will be added, multiplied with 10 value and divided by third input. Same input will go here. Both two will be added, multiplied with 10 and divided by third value. The second subsystem, we will make this as an atomic one. No further changes we will do for now, and to go for the code generation. For code generation, we will see our settings. So our solver settings we will not touch. We want to see the errors also. And here is the code generation. Target language compiler. I am going to use ert.tlc. Reason is I will be getting the code on the side by side with ert.tlc. So this change I will make and generate the code. Okay. Now in the apps we have to go and search for the embedded coder. Just in case if you don't see embedded coder over here, go to the drop down, search for the apps and you should be able to find it. From here, without doing any further changes, we'll generate the code and we are getting the error. For sure, the error says variable step solver. We have to use a fixed step solver with appropriate integration algorithm. So which means gives us an idea that we have to go into the model configurations and change the settings. We will go to the solver. First, we will say fixed step and then we will say discrete because we want to consider with some particular real-time hardware with which will have the fundamental sample time as a fixed value, and then apply. Now we'll go and generate the code. The code is available. We will check for atomic one. This is the main code function which will be untitled step function. Basically untitled is the model name and then underscore step function. We have two set of output. The first set of output is the out1, which is this one, and this one is calculated from the input with the basic mathematical formulas which we have given, a plus b into 10 by c. Now the out2, this out2 is created equal to out1, no optimization code. So first this is calculated and compiler understood this atomic subsystem is doing nothing else than this non-atomic one. So just assign this out2 value equal to out1. But this is with the code generation. So when we have enabled this treat as an atomic unit, we had this option code generation, function packaging. We have this as a default as auto. Now we will see inline how the code will get generated. If we see with inline, there is no change because this is the pink line which shows where and what change has been done from the previous code and looks everything same. Nothing has been changed. So inline and auto has no change over here. We will go for third setting and this time we will say non-reusable one. When we say non-reusable one, we get multiple options, and out of those, one becomes important for us, function with separate data. This will give more actions, but also it will result in some different code generation. So apply and do the code generation. Here we see the code has been changed a lot. First, we will go to the step function. Out1 is calculated as it is. Out2 is calculated as a function. This is untitled model name. Atomic is the subsystem name which is highlighting over here. Now this function, this is the void function, so that is no input argument is allowed, but inside it has calculated everything out to equal to same logic but converted as a single function. So this is the use of non-reusable function packaging. So where it creates this atomic unit code as one function, but it cannot be reused because this is the void function. You cannot pass the different arguments and just use same function for different set of inputs. There has been one more option which we saw, something similar. We will go for it now. Block parameter, code generation, make it reusable one. This time again, if we come to the step function, out one is as it is same because it's a non-atomic one, no operational optimization over there. But out two became one function with some set of inputs. So this is now parametric a function which where we can pass the arguments and reuse this function. That's where we call it as a reusable one. Untitled atomic, if we go and see over here, untitled atomic is get receiving three inputs and then a plus b into 10 divided by c. That's a calculation will remain same but as a parametric function. That is where this function can be used. So this is how the atomic subsystem enables you different function packaging. Thank you for watching. See you in the next video.